Hi, I am Syed on Maths Online. Today we will be dealing with discontinuous function. In the previous video also we have discussed about the discontinuous function, how to express the discontinuous function in terms of unit step function, and also to find out its Laplace transform. Few examples we have done in the previous video. We will continue with few more problems in this video. So let us start with the first example. The property for discontinuous function that I had given f of t to be equals to, it is f1 of t, that the value of t is less than or equals to a. You have f2 of t, where t lies between a and b. f3 of t, where t is greater than b. If this is a discontinuous function, you can rewrite the value of f of t to be equals to the first function f1 of t plus, you have to take the difference of the second function minus the first function, that is f2 of t minus f1 of t, times of it is u of t minus of a, this limit value. Then plus, you have to take the difference of the third function minus the second function, that is f3 of t minus f2 of t. It is times of u of t minus this interval that we are taking, t minus of b. So that's the function you have. So now based on this particular property, we'll take few examples. The first question is, express f of t is equals to 1, 0 less than t less than or equals to 1. It is t 1 less than t, t less than or equals to 2. It is t square, t is greater than 2 in terms of unit step function. In terms of unit step function, and hence find its Laplace transform. If you just try to compare the property above, just try to check the first value will be your f1 of t. So f1 of t in this case is 1. f2 of t will be t, and f3 of t will be t square. And what will be the value of a? So the value of a in this case is 1. And what is the value of b? If you try to observe over here, the value of b will be 2. So now if I try to rewrite the property, so we have the property f of t to be equals to f1 of t plus f2 of t minus f1 of t, u of t minus of a plus f3 of t minus f2 of t into u of t minus of b. Just try to plug in all the values that we have. If you try to plug in these values, so I get f of t to be equals to f1 of t is 1 plus f2 of t is t minus f1 of t is 1. It is times of u of t minus of a value will be 1 plus f3 of t is t square minus f2 of t is t. It is times of u of t minus b value is 2. So let us apply the Laplace transform. So Laplace transform of f of t is equals to Laplace transform of 1 plus Laplace transform of t minus of 1 into u of t minus of 1 plus Laplace transform of t square minus of t into u of t minus of 2. So I need to find out the Laplace transform of 3 different terms. So let me take this as say equation number 1. So first I'll try to find out the Laplace transform of 1, which is nothing but 1 by s. So I'll take this as equation number 2. So I have to plug in this value back in equation number 1 at the end. Then I need to find out the Laplace transform of t minus of 1 into u of t minus of 1. I need to find out the Laplace transform of these two functions. So therefore I will take this first function to be equals to capital F of t minus of a. So what is the value of a in this case? A value is 1. Here I will be taking, because I have already used capital F, so for convenience I will be using over here as capital G. So it is t minus of, because we are using b over here, in this case b value is 2. So I will be taking these two functions. So let us start with the first value that we have. It is f of t minus of a, that is t minus of 1. So its value is t minus of 1 itself. So now if I want to replace, because both are t minus of 1, so if I replace this t minus of 1 by t, so this value will also become f of t is equals to, right hand side will also become t. So we will take the Laplace transform. Laplace transform of f of t will be equals to Laplace transform of t. You already know Laplace transform of t is 1 by s square. Just using the property Laplace transform of t power of n to be equals to n factorial by s power of n plus 1. So using the property that we have, this will be acting as your f bar of s. So we know the property, the Laplace transform of f of t minus of a into u of t minus of a is equals to e power of minus of as into f bar of s. We know the value of a, so a value in this case is 1, so t minus of 1 into u of t minus of 1 is equals to e power of minus, a value is 1, so 1 times of s. F bar of s, just now we have calculated that as 1 by s square. So therefore we have got the expression over here, Laplace transform of f of t minus of 1. Its value we already know. I have taken f of t minus of 1 to be t minus of 1 into, it is u of t minus of 1. That is nothing but e power of minus of s times of 1 by s square. So equation 1, second term has been obtained. So I will take this as equation number 3. Now again one more expression we need to calculate from equation number 1. So let us try to find out that value also. So to find Laplace transform of, so go back to equation number 1 and check what is the value that we need to calculate. That is t square minus of t times of u of t minus of 2. This is the value that I need to calculate. So I have taken it as g. So g of t minus of, in this case your b value is 2. So t minus of 2 will be nothing but t square minus of t. But I have to make this as g of t. So since you are having minus 2, just add plus 2, which will be equals to, here also just add 2. So t plus 2 whole square minus t plus 2, which will be equals to, it is in the form of a plus b whole square. So it is a square plus 2ab, 2 into a into b, 2ab, plus b square, in this case b is 2, so 2 square. Next term minus of t, minus of minus will become, next is minus into plus will be minus of 2. So this will be nothing but t square plus 4 times of t. This is plus 4 minus 2 will be plus 2. This is minus of t. Or further, if you try to rewrite it, is t square plus 4t minus of t will be 3t. T square plus 3t plus 2. So here it is minus 2 plus 2 will cancel out. We will be getting the value as g of t. So now we'll take the Laplace transform. So Laplace transform of g of t will be nothing but Laplace transform of t square plus 3 times of Laplace transform of t plus Laplace transform of 2. So Laplace transform of t square will be using that basic formula n factorial divided by s power of n plus 1. N value over here is 2 plus 3 times of. So in this case n value is 1. So 1 factorial divided by s power of n plus 1. So 1 plus 1. Next Laplace transform of a will be a by s. A value over here is 2. So 2 by s. So you have 2 factorial is 2 by s cube plus it is 3 by s square plus 2 by s. So this represents your g bar of s. So now if you try to use the property over here, so you have Laplace transform of g of t minus of b u of t minus of b, because the second interval is b, therefore I am taking b over here. It is e power of minus of bs into g bar of s. The actual formula is e power of as into f bar of s. Because the interval I have taken b and instead of f I have taken it as g. So this will be your formula. So now just try to plug in the values that we have obtained. So this is Laplace transform of g of t minus the value of b that we have. So the value of b, go back and see what is the value of b we have. The value of b is 2 into u of t minus of 2 is equals to e power of minus of 2 times of s. G bar of s has been obtained over here. You have 2 by s cube plus 3 by s square plus 2 by s. Whereas this g of t minus of 2, again go back to the equation and check it. We have taken the value of g of t minus of 2 to be equals to t square minus of t. It is times of, it is u of t minus of 2. It will be nothing but, you can write down this expression as it is, e power of minus of 2s times of, it is 2 by s cube plus 3 by s square plus 2 by s. Take this as equation number 4. We need to just plug in equation number 2, equation number 3 and equation number 4 in equation number 1. Check all these equations. So I will be getting equation number 1 to be Laplace transform of f of t is equals to. The first term is your equation number 2. So just plug in equation number 2, which is 1 by s. Next is your equation number 3. So just check equation number 3 is e power of minus of s divided by s square we have got. Now equation number 4 that we have is e power of minus of 2s times of 2 by s cube plus 3 by s square plus 2 by s. That is the final solution. Let us move on to the next question. The second question is express f of t is equals to cos of t, 0 is less than t, t is less than pi, cos of 2t, pi is less than t, t is less than 2 pi. Cos of 3t, t is greater than 2 pi. In terms of unit step function, and hence find its Laplace transform. So here if you try to check, your f1 of t value is cos t. Your f2 of t value is cos 2t. Your f3 of t value is cos 3t. Check the values of a value will be pi, this particular value. Your value of b will be 2 pi. So now if I try to use the property, f of t will be equals to the first function f1 of t plus the second function minus the first function into u of t minus a plus the third function minus the second function into u of t minus of b. Just plug in the values that we have. F of t will be equals to f1 of t value will be cos t plus f2 of t is cos 2t minus f1 of t is cos t into u of t minus a value is pi plus f3 of t is cos 3t minus f2 of t is cos 2t into u of t minus b value is 2 pi. So let us apply the Laplace transform. So Laplace transform of f of t will be equals to Laplace transform of cos t plus Laplace transform of cos 2t minus cos of t into u of t minus of pi plus Laplace transform of cos 3t minus cos 2t into u of t minus of 2 pi. So we need to find out its Laplace transform. Let us take this as equation number 1. First let me find out the Laplace transform of the first term, Laplace transform of cos t. So cos at we know its formula is s by s square plus a square. So here coefficient of t is 1. So plus 1 square. So you'll be getting s by s square plus a square. So let us take this as equation 2. I have to plug in this back in equation number 1. That I'll do it at the end. Now I need to find out the second term. To find Laplace transform of cos 2t minus cos t into u of t minus of pi. So I'll be taking this function to be equals to capital F of t minus a. So in this case your value of a is pi. So it is t minus of pi will be equals to cos of 2t minus cos of t. But because you are having t minus of pi, to get the value of t you have to add a pi over here. On the right hand side also I'll do the same thing. T plus pi minus cos of t plus pi. This will be nothing but cos of, so 2t plus 2 pi, or I can write it as 2 pi plus 2t just for convenience, minus this is cos of pi plus t. The first term which is there, it is in the form of cos of 2 pi 360 plus theta, and we know cos of 360 plus theta will be cos theta itself. Next we are having cos of pi plus t or pi plus theta. So cos of 180 plus theta will be minus cos of theta. So using this basic formulas, I can just plug in over here. This will be nothing but cos of 2t minus, because you are getting minus sign over here, it is minus cos of t. Or further, if I try to rewrite, it is cos of 2t minus of minus will become plus cos of t. So this will be nothing but your f of t value. This is f of t, because this negative pi, positive pi will cancel out. I need to take the Laplace transform. So Laplace transform of f of t will be nothing but Laplace transform of cos 2t plus Laplace transform of cos t. So using the basic formula of cos at, it is s by s square plus a square. A value is 2, so 2 square, plus here it is s by s square plus a square. So in this case the coefficient of t is 1, so 1 square will be 1. Or if I try to rewrite this one, it is s by s square plus 4 plus it is s by s square plus 1. So this will be nothing but here capital F bar of s. So if you use the property Laplace transform of f of t minus of a into u of t minus of a will be equals to e power of minus of as into f bar of s. So this Laplace transform of f of t minus a value in this case is nothing but your pi. T minus of pi into u of t minus of pi is equals to, it is e power of minus of pi s. F bar of s value already got over here. So it is s by s square plus 4 plus s by s square plus 1. So take this as equation number 3. I need to calculate one more expression to find the third term of equation number 1. So go back to equation number 1 and check the third term. The third term that we have is Laplace transform of cos 3t minus cos of 2t times of, it is u of t minus 2 pi. This is what I need to find. So here I will be taking this function to be g, so t minus b, but we know b value is 2 pi. So here b value is 2 pi, so g of t minus of 2 pi will be equals to cos of 3t minus cos of 2t. We can just add 2 pi, so add 2 pi, so it's plus 2 pi is equals to, on the right hand side also add 2 pi minus, it is cos of 2 times of t plus 2 pi. So this 2 pi and 2 pi will get cancelled. You will get the value as g of t. That is nothing but, it is cos of, we just try to multiply it, is 6 pi plus 3t minus cos of, it is 4 times of pi plus 2t. But we know cos of 2 pi or 2n pi plus theta, its value will be cos of theta itself. So whenever you have even multiple of pi, cos of 2n pi plus theta will always be in the first quadrant. In the first quadrant, cos is positive, therefore we will be getting cos theta. So applying that rule over here, so this will be equals to cos of, you get it as 3t, cos of 3t minus over here you will be getting cos of 2t. So apply the Laplace transform. So Laplace transform of g of t is equals to, it is Laplace transform of cos 3t minus Laplace transform of cos 2t. So using the formula of Laplace transform of cos at is s by s square plus a square. So here a value is 3, so 3 square minus, it is s by s square plus a value over here is 2 square. Or further, if I try to rewrite it, is s by s square plus 9 minus, it is s by s square plus 4. So this will be nothing but your g bar of s. So now if you use the property, we have Laplace transform of g of t minus of b into u of t minus of b is nothing but e power of minus of bs into g bar of s. So it is Laplace transform of g of t minus b value is 2 pi into u of t minus of 2 pi is equals to, it is e power of minus of 2 pi times of s into g bar of s that we have calculated over here. It is s by s square plus 9 minus s by s square plus 4. So now you can just try to plug in this values back over there, or if you want to rewrite this value of g of t minus of 2 pi, you already know the value that you have taken for g of t minus of 2 pi to be equals to, it is cos of 3t minus cos of 2t times of u of t minus of 2 pi, and right hand side will remain the same as it is. It is e power of minus of 2 pi s, it is s by s square plus 9 minus s by s square plus 4. Take this as equation number 4. Now we need to substitute equation 2, 3 and equation number 4 back in equation number 1. Check out all these equations. So your equation number 1 imply Laplace transform of f of t is equals to, the first term will be your equation number 2. So check what is equation number 2. Are you getting equation number 2 to be equals to s by s square plus 1? Check it. The next term that you have is your equation number 3. So plus, check your equation number 3. It is e power of minus of pi s times of, it is s by s square plus 4. It is s by s square plus 1. Then your equation number 4 will be plus e power of minus 2 pi s by s square plus 9 minus s by s square plus 4. That will be your required solution. But if you want to further simplify it, just for your convenience, if you want to simplify, you can simplify that one. S by s square plus 1. So s is common in the second term. If I take s common, so it is s e power of minus of pi s. You have 1 by s square plus 4. It is 1 by s square plus 1. So here also, if you want, you can take s common outside. S into e power of minus of 2 pi s into, it is 1 by s square plus 9 minus 1 by s square plus 4. That's the required solution. That's all I have for today. Thank you.